Welcome back to the post-lunch session for Hello CBG Webinar. Thank you very much once again, all of you being here. I still see close to 110 people. I'm sure it's going to be 130, the number we had in the morning. So just going through the list of people who are here, and it's like a very diverse set of people, all the way from the government. We have from, as I said, Ministry of Petroleum and Natural Gas. We have from the railways. We have two different railways represented here, one from north, one from south. We have companies from the food industry, from animal feed, from agriculture, from sugar. That's not surprising. Power companies, engineering equipment, large multinational global firms like Mitsubishi, of course, our own large firms like Reliance and Thermax and Praj. We have at least 3 IITs researchers represented here, and large EPC firms like Engineers India. We even have legal companies. That's a pretty interesting number. That's a pretty interesting addition. We have financial investors as well, both from the debt side as well as equity side. We have venture capitalists, at least 2 or 3 venture capitalists here. So I think it's a pretty large set of sectors who seems to be interested in CBG. I believe some of you had trouble while getting in the morning. It took some time for my team to all of you inside. My apologies. We had not realized that we would be running beyond 100 people. So I think we had taken a package where it allows 100 people to come together. We were so confident that we'll have not more than 30, 40 people. We never bothered, and we have, well, know the numbers. So apologies. In a way, it was a pleasant problem to have so many people, but it might have delayed some of your entry. We will be sharing all the details with you of whatever went on over here, so you will have lost absolutely nothing. My pleasure now to invite folks, Joseph and Hans. Joseph I've known for a long time. I've known him for now perhaps about 10 years. He's, of course, from my city, Chennai. So he went all over the world to study. He went to Sweden to study, and I believe he still does a good amount of work in collaboration with Sweden. I remember he getting a lot of trade delegations from Sweden to visit here on the technology front. And most importantly, I think he has been running his biogas firm, where he has done wonderful work both in India, and I understand he has worked in Brazil as well on some pretty large scale biogas plants, biogas and CBG plants. So it's my pleasure to have Joseph, along with him, his German colleague. It's a pleasure to say hello to you, sir. I haven't known you before, Hans, but what a good opportunity to say hello to you and know you too. Went through Hans's biodata. Wow, he's been working in biogas for a very long time. The earliest entry says he was doing something to do with complex fermentation mechanisms in 1989. I'm sure most of you guys weren't born by then. So that's a phenomenal amount of experience Hans brings with him. He has also been beyond technology work. From his resume, I could see that he has also been on the industry association front. He has been holding senior positions in the European Biogas Association industry bodies. Such a pleasure and privilege to have Hans here. I'm sure all of us can benefit from the rich experience you had in the sector. Joseph and Hans, over to you.
Thank you, Narsi. Thank you very much. Can someone enable to share the screen, the presentation?
So we will be running it for you.
Okay, fine. Yeah. Yeah, so Narsi, very good afternoon and good afternoon to everyone. And thank you for having us to be part of this program. So we would like to, extend our thanks to EA and his team. As Narsi told, I think we know each other for 10 to 11 years. So Narsi has been doing a lot of good work in renewable energy space. And now I hope in biogas, he could continue to do, helping companies to enter into this business and become successful. Yeah. Yeah. So the brief agenda would be that we would be covering, myself and Dr. Hans will be covering topics related to mainly on the digestion side, the fermentation process involved in the biogas process. So in this, we will cover briefly about pre-treatment technologies, very briefly. I think some of you would have already heard and discussed about about this. And then we will discuss about feedstock preparation, pre-treatment methods, and then storage related things. And mainly, of course, the digestion part with the feedstocks, solid feedstocks, mainly Napier and paddy straw, of course. We will also touch upon slightly on press mud if required and if time allows. And again, MSW if there is time on that as well. And also discuss about our specific core offering, what we are currently doing in India using so-called semi-dry fermentation process or high load reactors. It's also called as high load reactors, and some of the advantages of it by for using solid feedstocks. And also finally, we would share some of the work we are currently doing in India at this moment as well. Yeah. So next slide, please. Yeah, so myself, talking about myself, and Narsi has given a very detailed introduction. So to keep it short, this is my second biogas venture. In the first biogas venture, I had a joint venture with our Swedish partners where we set up small decentralized biogas plants, close to 100 we set up in the last 6-7 years. Of course, the larger industry or the larger biogas plants or the Satat scheme was not in place or had a proper shape at that point of time. But that gave us a good amount of time to prepare for this industry and knowing what is here in the market and what is the requirements and so on. So that's when, I had been in contact with Dr. Hans for almost 13 years. So we know each other for 13 years. So we have been ourselves very patient in this 13 years to enter into the Indian market, even though the market was not ready. And what I would do is maybe let Dr. Hans briefly introduce himself on this specific slide about him and his work. Yeah.
Thank you, Joseph. I'm very long in that business. I'm an old man and working long in that business. I made my PhD in biogas. I made a mathematical model of the process. And of course, I had to evaluate that model, and the data of calculation and the experiment fits quite well. So I think I understood the process. And in the meantime, I was working as consulting engineer, as plant operator for one of the biggest German biogas MSW plants in Germany, near Berlin. I founded several companies, for example, Agrafirm Technologies, and I'm operating, in the peak, I was operating 14 biogas plants. Currently, I'm operating my own and the plant of a friend. And I was working in the whole world in biogas business, from Brazil, Indonesia, India, whole Europe, Eastern Europe, Ukraine last years. I made many projects in Ukraine. So I was in the whole world active in biogas business as consultant, as EPC company, and as plant operator. Yeah, Joseph.
Yeah, so we are based in our Indian team is based in Bangalore. We are operating from Bangalore, even though J&W is originally a registered Chennai company, but our operations are from Bangalore. And Dr. Hans sits in Munich. He operates from there. Yes. So next slide, please. Yeah. So what is it we are offering currently or our services for the Indian market here? So our specialization is in offering the core anaerobic digestion process, design and engineering, and also supplying critical components related to the digestion process. And then we have a tie-up with the EPC. We have one of our EPCs is 3G Process Engineering based in Mumbai, where we work with them for setting up projects in India to execute projects where we do the basic design and engineering, and the project execution is done by our EPC partner. And also we have in India, we have done consulting for pretty large investors and EPCs for several big projects this year currently, working on optimization and of their existing plans and proposing new designs for the upcoming plans. So that has also given us a very good insight by working with the large investors on plans which are already running or commissioning and troubleshooting them. That's something we are also doing. And also we provide support for biogas operators with biological commissioning, and also to increase plants to full load, because we see that India is in a very early stage in biogas business, and there are a lot of things which have been tested and tried in several plants. So based on the experience from Dr. Hans and his team, so we could add some value wherever possible in a small way to optimize the plants and bring them to full capacity if feasible, provided the technology and designs allow them. And also we also do long-term operation of biogas plants in behalf of investors. And finally, we also sell specific micronutrients which are important for the biogas process in itself, and also spare parts and queue equipments for the biogas AD related components. So in brief, this is the range of services we offer. At heart, we are more a company which designs and does design engineering for AD plants on both dry fermentation and wet fermentation, even though dry fermentation is our specialization. Yeah, next slide, please. So we will touch very briefly on the feedstocks because this might have already been discussed during the day. We'll not go very detailed. I mean, if there is an additional value from the slides which is going to add, then that could add value. So these are the common feedstocks. What you see here, paddy straw is discussed a lot. I know that in India in the last years, of course, this is available in large volumes. Transportation and storage and purchase is something, the prices and the operational cost of the plant is dependent upon the cost of the feedstock. That's one thing. And also the main thing is the technology, choosing the right technologies for the paddy straw treatment, which we will discuss in the coming slides. So press mud and cane thresh, again, we all know that it's been there for many years. And it's one of press mud, at least, is one of the very easy feedstocks to digest and handle. It's mainly concentrated in the sugar mills, which in itself is a separate market segment to work on. And then Napier grass, which is again a very humble crop, but which has been discussed more widely than paddy straw of late in the last 1 to 2 years. We could call it as an energy crop, similar to how they have energy crops in Germany and other countries. So it's a very good feedstock if it can be grown in the larger scale and larger volumes, and right designs and technologies are used for the digestion. And also, I guess in Napier grass is something, the grass family based feedstocks are already been tried and tested for many years in Europe. So I think we should try to, if possible, try to take some learnings from them, not to kind of reinvent the whole wheel on digestion and feeding and so on. So these are the very commonly used feedstocks in India for biogas production. So I would now request to move to the next slide, please. So I will let Dr. Hans take over from here on this upcoming slides here.
Yeah, thank you, Joseph. What you see on the pictures here is a paddy straw storage facility in India and a cane thresh storage facility in Brazil. The Brazilian business I made about 12 years ago now. That time we just tested the cane thresh in the biogas plant, and we saw that the gas yield is similar to the straw. The wheat straw or paddy straw doesn't matter. There are several technologies to prepare this type of feedstocks to be used in the digester in India and everywhere in the world. The first point is it's crushed. The particle size has to be reduced by rotary shears, by hammer mills and other shredder technologies. very often in combination with further decomposition technologies, for example, by an extruder. I made, 10 years ago, I made many tests with thermal disintegration. It's a steam explosion technology to increase the biomethane yield, or even the biological one, the hydrolysis. The idea is to increase the gas yield in comparison to just to fret a little bit and digest it, and to improve the digestibility in the tank. But all these technologies are very expensive in investment. They have a very high power consumption, and the wear and tear is very high. So my experience in Germany with straw digestion is the costs for the pre-treatment is about, let's calculate in rupees, it's about 600 to 1,000 rupees per ton of straw minimum, only for the shredding, if you take all the costs into account. So the question is it profitable to do? Is the additional gas yield paying these costs? A very important point. That must be tested individually and discussed individually for each project. So next slide, please. That's the press mat storage yard we had in the plant in Brazil. I was working there between 2010 and 2015. Around about 400 working days I was in Brazil. The press mat itself is a fine feedstock for a biogas plant. It's homogeneous, it's simple to handle, and so on. Gas yield is okay. A little bit tricky is the storage. The storage yard here is, in that picture, operated not in the best way. What you see is there is a tractor on top of this hill. The idea is to compact the material and later to cover it with a plastic layer to avoid oxygen coming in, and to avoid composting processes which would reduce the gas yield of the press mat. What you need for a digestion of press mat, you need the storage yard to cover the time when the sugar mill is stopped, when there is no harvesting season. In India, I learned it's about 7 months. In Brazil, it was 4 to 5 months. So, but you need a quite big storage yard and the right way to store it. To keep the biogas yield in the press mat, we use an ensilaging process, like the lactic acid fermentation process, to drop down the pH a little bit and to avoid biological disintegration there. So what we need is a good compaction of the material, airtight covering, and at the end, when you open the silo and start feeding from the silo, you need a good silo management. What you here see, for example, is the front of the silo is not plain. You should try to open only that part of silo you need, not too much, to avoid composting processes which would destroy the energy in the press mat. Next slide, please. Yeah, these pictures are from my own plant. Harvesting season, I think it was last year in my plant. If I think I have to handle a biogas plant in India, my plant is a small one. It's equivalent of 2.5 tons CBG per day, so it's 600 kW electricity power I'm producing, and I need about 10,000 tons of feedstock per year, so about 30 tons per day. Quite small in comparison to plants in India, where we talk about 100 to 300 tons of feedstock per day. This has to be handled. This must be transported and so on. So I think the biggest challenge in India, handling Napier grass as an energy crop, will be the harvesting technology. What we are doing is we have very high potential shredders from Klaas or John Deere or from Krone, very heavy machines with 800 horsepower, driving on the field, shredding, cutting the material, blowing it in the trucks you see on the picture. The trucks bring it to my silo. And we compact it there. You see this wheel loader on one of the pictures, modeling the hill and compacting the hill. in my plant to harvest the whole feedstock demand for the year, I need about 10 to 12 days, 10 to 12 harvesting days. So it's really 800 to 1,000 tons per day we are harvesting, compacting, closing. Then we have the silaging process, and after 4 weeks roundabout, the stabilization process is done, and we can use the material for the whole year. The digester can be fed directly from the silo. There is nothing, no additional pretreatment necessary. If it's cut it in the right way to 10 to 20 millimeter particle size, there is no sense to flatter it more to make it finer particle, because the gas yield will not increase with this type of feedstock. Next slide, please. That is the way we feeding the digester. We are talking about solid feedstocks, not liquid ones. And that picture is the second plant I'm operating. We bought this plant from insolvency in 2020, and we had to change the technology. It's only one of the examples. I know many such examples. We changed the feeding system because they only had solid feedstocks. And this to put the solid feedstock into the digester with a wet technology is a little bit tricky, and therefore we added this 64 cubic meter solids feeder with screws to feed the digester directly. We only fill this feeder once a day fully, and we have this about, for this plant, 45 tons per day we need in the feeder, and then the feeder feeds automatically. The filling is done with a wheel loader, or in that case with a tele loader. The feeding from this solids feeder is continuously, so it's a pushing floor and a feeding screw to bring the material continuously or semi-continuously, one small amount each hour into the digester. The second option would be to use a wet feeding system. So also this feeder can bring the material in a mixing pump, like a biomix, mix it together with digestate and pump it into the digester. That is an interesting technology. If I have additionally a bigger amount of liquid feedstock, then it's fine to do this. In our case, it's not the best and not the most efficient technology. Next slide, please. Yeah, that was our experience. Let's talk about digester technology. The same plant you saw before. When we got the plant, when we bought the plant, we opened the tank because we had big problems with crusts on the surface of the digester. That was 2 to 3 meters thick, very, very strong materials. So we had to open, and that time we didn't have the right technology to optimize the process. So we had to contract the company with a very strong mixer on a truck with a hydraulic arm to mix the digester, and a big separation machine on a truck coming on our site, removing this crust. It was 3 days, 30,000 euros to remove this crust. To restart the biogas production in a feasible way. Then we changed the technology. In that plant, it wasn't able to install proper mixing system. So that was a mixing system, taking liquid from the bottom of the tank, pumping it and spraying it on the top. So we doubled the capacity to increase the mixing quality. We changed the feeding system. We put one mixer in to mix the fresh feedstock directly into the liquid. Then the most important point, we installed the separation technology to remove continuously all the not digestible fibers. And with this technology, we was able to increase the capacity of that digester. We doubled the capacity in half a year. So the most important point for the digestion part is the right mixing system. If the digester content is not homogeneous, you never will get a good performance. So you need a very good mixer, high-end technology with long lifetime. You shouldn't remove it each 3 months to repair. That's opening the tank, losing gas and so on. That's too expensive. Then it should have low energy costs, because the energy demand on the digester section is 50% digester mixing, roundabout. So That's the point where you can reduce the costs. And they must be able to avoid such crusts, so they must be able to handle also high viscosities. So the right mixer, from my point of view, is the key for the success of a biogas digester. Next slide, please. That's a plant in Ukraine I made in 2020. That's a big plant. On one of the pictures, the two digester with the dark gas holder was existing there. That was a pig manure plant with a wet fermentation system, with submerged mixing systems, and a small solids feeder using different solid feedstock like cow dung, solid cow dung, and a little bit maize silage and such materials. That was a big problem for them. Then they got crusts, like you saw in the picture before. Really strong crusts, big problems. And they would like to increase the capacity. When I came, it was a 1.2 megawatt plant. Electricity production, a cedar green CHP on one of the slides, and in a new digester, my new digester with the feeding system in front. We add the 5,000 cubic meter side entry semi-dry fermentation digester with the solids feeding system. We use the solids only in our digester, and the other two digester are only for the liquid material. And we increased the capacity to 3.9 megawatts. So 3.9 is about 18-20 tons per day CBG equivalent. So you need the right mixing. That's our mixer. There are other mixers on market. Of course, we are sure that our mixing system is the best and the most profitable, but that must everybody decide for himself. One additional point is you need this separation system if you handle solid feedstocks, because in the solid feedstocks you have the lignin in, a not digestible part, and you will have not digestible fibers. And if you don't remove, you will not be able to handle the viscosity in digester. Besides, you would put water, for example, in, but putting water into the digester means I need the water and have to handle the digestate. I have to transport it, I have to get rid of it. It dilutes the nutrients in the digest, so that's really not profitable. Okay, next slide, please. Yeah, that's the separation system. Again, that plant we was optimizing the last 3 years. It's a very simple machine, a 40,000 euros machine, one machine for that plant, 1.6 megawatt plant. And this machine makes it, avoids all the crusts since 2 years in that plant now. This simple machine, but you must install it in the right way and operate in the right way, but it's quite simple to do. Without the separation machine, you would have problems. You would have the problem with the crusts, and you would have a problem with the handling of the digestate. Using the solid feedstock, if you don't put a big amount of water in, you have to handle this digestate, use it as a fertilizer. But this thick sludge, there is no machine to spray it on the land. So what we are doing is we separate the solids, use the solids in the standard technology. We spray the solid dung on the land, existing technology, and we have the liquid material from the separator, the permeate, which is able to be used like liquid cow manure, also spraying on the land as fertilizer, and of course, part of it for recirculation to control the viscosity in the digester. Next slide, please. Okay, that's my own plant in northern Bavaria, constructed 2008, very small plant. What you see there is the feedstock area. It's a 10,000 cubic meter feedstock area. We fill it. We have two major harvesting seasons. The one is the triticale seasons, end of June, beginning July. And the second is the maize season, end of September. And end of September, the silo is full. And we feed the plant only from the silo. No truck is coming to bring. And what you see also on in this feedstock area, this brown place, that's the separated digestate, the solids. Over the winter, we are not allowed to bring it to the fertilizer to the land, so we store it in the open spaces in the silo. very simple. Then we have the feeding system. It's just in my case a 50 cubic meter feeders to feed with a screw, then directly into the digester. The feeder is filled with the wheel loader once a day. Then it runs automatically. We have the digester, in my case, a very small one. That time we made concrete roofs, a little bit expensive, but that was our idea that time. And then I have a CHP, a Jenbacher CHP 637 kW installed power. Then a separation system, of course, and the big tank there is at the end only the storage tank for the liquid digestate, because we have to store the liquid digestate for 9 months by law. So we must have the capacity. So therefore we need this big tank. Very simple, such a plant, low investment. Of course, the feedstocks in Germany are quite expensive. So we can earn money with this plant, but you must operate it in the right way. Okay, next slide, please. Yeah, I would like to talk a little bit about wet fermentation, standard wet fermentation, and semi-dry fermentation. If I use a standard wet fermentation plant, then it's the right, using liquid manure, using spent wash. Sorry?
Go ahead. Go ahead.
Using spent wash or something, some other liquid feedstocks, the wet fermentation technology is the right technology, no doubt. But using this solid digestate, solid feedstocks, you must think about optimization, the digestion technology to your feedstock. That's what we did in 2002, 3, 4, when we developed this technology. The idea was, if we are able to increase the dry matter in the digester by keeping it mixable, we can reduce the digester size. That's the miracle. If I'm able to mix the material in the digester with high viscosity, high dry matter content, I can reduce the digester size by keeping the same HRT. I need the HRT for the digestion, for the gas production. So I cannot reduce the HRT. If I have big amount of liquid, I have to increase the digester volume to keep the same HRT. So in our case, the result of that process was that we have only around about half of the digester volume in comparison to a wet fermentation plants. If we digest the same feedstock, same solid feedstock, with the same HRT, with the same gas yield, the plant becomes much simpler. The energy demand for the digestion section becomes much lower, around about half of the energy. Of course, you have only half of the mixer in the digester. So that's the core difference between the technologies. But of course, we have to use more expensive technology. I think that's on the next slide. What are the advantages of this dry fermentation, semi-dry fermentation process? We reduce the digester size by 50%, so we need you have lower costs for the digester section, for the construction. The electricity demand for operating the digester is drastically reduced. We can with the same tank, we can double the output with solid feedstock with our technology. So the refurbished technology at the end, if possible. We are very flexible in the feedstock demand. For me, it doesn't matter if I use cane trash, paddy straw, Napier grass, press mud. The press mud is special, it's quite simple, but all the others I can mix as I like. I must only adjust a little bit in the operation, but not in the technology. Okay, next slide, please. We have several pictures of very old projects we made. That's the plant in Brazil I was working for many years. When I came there, the plant was under construction. The foundations for the digester was made. The design was made. And I was only asked to optimize, because they saw that with the first digester, which was nearly finished that time, they had several problems. From this very short consulting contract, it came to a 5 years intensive cooperation. What you see there is the digester section for the press mud and cane trash digestion. We had a wet fermentation there. We mixed cane trash, press mud, and spent wash. To be honest, we had to change this in the first years because the cane trash in that mixture was not mixable in that tanks with that mixer. So we had to change drastically. On the second picture there, you see the tower is the desulfurization unit for the gas from the spent wash digestion, and the lagoon is a spent wash lagoon. That was, to be honest, that plant at the end was a pilot plant for my client, a 4 megawatt electricity production pilot plant for the residues of sugarcane processing. We all learned many things about the digestion of these feedstocks in that 5 years. Next slide, please. That are plants I was responsible for in Europe. The MSW plant near Berlin, Fürstenwalde, I was operating between 1997 and 2008. We had a pulper system. It was at that time it was the biggest MSW plant in Germany. In the meantime, there are bigger ones, but at that time it was the biggest with about 80,000 tons per year theoretical capacity in a mixture of manure, fat sludge, chicken waste, MSW, and so on. Quite crazy mixture. We had a pulper system to remove the impurities from the MSW and to get a pulp which is digestible. There was a wet fermentation system. We had also a hygienization tank for these food residues from restaurants and so on. And the other picture with the big tanks is a plant in Denmark we made in 2017. That was a project of 120 farmers. They delivered 1,100 tons of pig manure per day. And the pig manure is very low in energy, so we had to add a little bit solid feedstocks. That was the challenge that time, to mix it in the right way, to keep it mixable and so on. Well, a little bit of challenge to do. At the end, we was able to digest about 140 tons of straw and this big amount of pig manure. Next slide, please. Yeah, that's another MSW plant nearby my own plant. It's a typical pulper-based plant in Germany, 100 tons per day MSW, also a mixture like in my own plant in Fürstenwalde from source-separated MSW, sludge from the flotation equipment in slaughterhouses, kitchen waste, and so on. I'm working together with the new owner of the plant since several years now. I think it's 6 years in the meantime. He bought the plant with a very, very bad performance. And we had to optimize it step by step. For me, it was an easy job because I had my 10 years experience in operation such a plant. So I could tell him what to change in the plant to be successful. Okay, next slide, please. Yeah, Joseph, you should take the word.
Yeah. So perhaps one of the last slides, I guess the last slide. So, so what are we currently doing in India here? We are working, or we worked on assignment with one of the reputed investment or EPC companies to design and optimize some of their existing plants which are already in operation, and also for the new upcoming project design. This was done over a period of 6 to 7 months. And other than our own projects, so we are working with one of our clients in UP in Lucknow to commission our first project, which is technically designed in the sense civil works is done for 18 TPD, but the first phase of commissioning will be 6 TPD. Maybe it will take more than February at this stage, maybe March or something we are looking at. And then we have other projects coming next year of 3 numbers of 10 TPD output and 1 of 20 TPD CBG output in AP and Telangana region. And also we recently signed another project near Chennai. Interestingly, in my hometown near outside Chennai, near Changalpat last week. So this is a 6 TPD Napier grass plant which will come out there as well. And we have other multiple projects in discussion stage. So this is some of the work we are currently doing in India.
Now we have Nursi for the Q&A session.
Yep. So good. We have a lot of questions. I would have liked somebody else to also involve themselves in Q&A, but perhaps I can take it this time. A lot of questions once again. Of course, these two teams, one from JNF, the other from Marka, I think they covered something that everybody is very, very keen to know. Of course, the topic is around lignocellulosic feedstock, but eventually the key questions from investors come to, okay, kitna deta hai, how much can I make, what is the payback period? So firstly, thank you very much. I think it was an intensive last 1.5 hours by you two teams. Firstly, thank you very much. Lots of questions have been put down. There have been a couple of questions I have had as well. Maybe I should go to Srinivas, because yours is something where I'm sure many of these guys are having it in their lips. So let me shoot it out. You mentioned 6 years as a more conservative number you would take when it comes to when it comes to payback period, correct?
Yes.
Now, this is for what? Conventional MSW based thing, or is it for the paddy straw kind of project you're talking about?
Sir, basically, I was targeting paddy straw as well as Napier grass plants, because the cost of the raw material people are assuming at a very low level, low price. Secondly, the operational expenses, whatever I have seen, I have been invited as a third-party investigator as well as by a few of the financial institutions. So I can see the cost of the operational cost which people are assuming or considering, it's way very less or very low. So almost I can say that 50% to 60% or somewhere between 45 to 55% of your revenue would be your operational expenses when you're targeting these two feedstocks or raw material.
No, I mean, in fact, I'm saying it looks very good to me, 6 years, because many times when I do the numbers with some of these guys, I would have actually happily taken 6 years. It comes to much more than that. Maybe I'll come back to slightly later. It looks like Hans has to move on. So why don't I go to Hans and then come to you? Is that all right?
Sure.
I have a follow-up question on that. So Hans, thank you for joining us all the way from Germany. You guys finished your presentation with German precision precisely at the allotted time. Very good. It's so good to see so much of work you have done. There are questions that have been put up for your presentations. Your slides has. Let me see what best I can choose from that, so that we use the time very well. You mentioned about cane trash in one of your examples that you had mixed with press mud and spent wash. Now, how successful was this project?
Yeah. I'm on mute, I think. Okay, so I tried to stop this because in that case in Brazil, the mixing system was not able to mix a good mixture of these feedstocks. So if I remove the cane trash, I could increase the capacity of the digester drastically, because the cane trash, the fibers, increased the viscosity so crazy high that the additional gas yield I couldn't realize, because I had to put much more spent wash to keep it mixable. It's just a question of mixing of the digester. It's a question of using the right mixing system. In that case, the decision was make the spent wash with the press mud, and it's fine, and you have the best gas yield.
So, in hindsight, would you recommend cane trash as a partial feedstock at all or not?
I would prefer to use cane trash as single feedstock, mono fermentation of cane trash.
Okay, so
perhaps with straw, because it's very similar, but cane trash normally is available in big amounts in the sugar mills, so you should do it as a mono feedstock. You can design the plant directly
All
on the
right, got it, got it. Because
and
in
it's
India as well, we have, as you know, India is along with Brazil one of the leaders in sugar production.
yeah.
We have a lot of cane trash, and it has not been valorized very well. That was one question I had. The second was, you had also mentioned in one of your slides that there was a Napier grass plant that you had put up, though it was smaller in scale. Was there a pre-treatment for that Napier grass plant, or was it fed directly? How was the construction?
For the Napier grass is a fine, nice energy crop. It's very similar to the feedstocks we use in Germany. It's not so simple than maize silage, but very similar. What I'm using is triticale, is clover grass and other types of grass, like Sylphia, an American prairie grass. Very similar to that. That's simple to digest. The question is how to harvest. We harvest mechanically, cut it to 10 to 20 millimeters, make silage from it, and from there we directly feed it into the digester. No additional pre-treatment necessary.
Wow, that's very
It gives
interesting.
no sense. If you do it, you will waste money.
So the Napier grass you are talking about in Germany, Joseph, is it something similar we have in India? Is it a different kind of a Napier grass? If it doesn't require a pre-treatment in Germany, does it require one in India? Any ideas? Any of you guys, Srinivas or Joseph?
Yeah, so grass per se, the Napier grass, when you look at the DM and ODM consistency, if you've seen the grass or maize grown in Germany, so they are closer in terms of the nature actually. Of course, the gas yields are completely different. The ODM and dry matter, the organic dry matter is quite high in maize. The gas yields are quite high in maize. But what's happening according to our understanding is many people are using so-called wet, that's a very generic term to use, but a submersible agitator or a recirculation pumps. So if you want to feed into such digesters, what you have to do is you need to pulverize it or pulp it, or they don't use a solid feeding system. There is no solid feeding system for the reasons which Srini was saying. They again think it's expensive, and adding some long-term equipments or robust equipment is expensive. So they have to pulp it, pulverize it, and then pump it into the digester, for example. So, but even in Germany, a typical so-called wet fermentation always has a solids feeder. That's solids feeder is something the concept is not in India, because it was again one plant before 12 years came in Varna, everyone saw the pre-treatment in a mixing pit, and that became a standard that everyone tried to do the same thing for the years. And I know Srinivas is laughing because he knows this as well. So that has become a standard that everyone does the same thing. So in short, the Napier grass per se doesn't need this pre-treatment if you're shedding it and taking it in a right size into the digester. As Dr. Han said, harvesting is the key. How are we going to harvest? I'm not sure if that's kind of figured out in most of the cases, but people need to have proper harvesters to do this job. Yeah.
Last question to Hans, just in case you want to make a move on. You had also shown us large piles of press mud, where you mentioned that the covering of press mud is a very important component. There was a question from somebody, and they said, whatever you do, the press mud, there is going to be some sort of anaerobic activity, and it is going to release biogas. What is the point in covering it?
So we must stabilize the press mud. So we must avoid that composting processes removes the digestible organic. That can be done by this ensilaging process. So it's a lactic acid fermentation, which happens everywhere. You can put bacteria in or not, doesn't matter. If you compact the material and avoid oxygen or air coming in and coming on the surface, you avoid this composting process. You get this lactic acid fermentation process. This drops down the pH and stabilizes the material. So to keep the gas yield in, compact it and cover it, and you're fine. If you don't cover, we lose the upper 1.2, 1.3 meters as a good quality feedstock.
Got it. Thank you very much, Hans. Those are all the questions that are directed directly to you. Just in case you want to move on, was a pleasure having you with us. And I'm sure India is going to see a lot more of you as we go along. Thank you.
Thank you very much.
So, guys, a couple of more questions to you guys, and then we can probably wrap this up. Lots of questions, as I mentioned. One for Srinivas, continuing with it. You see, can you take a couple of more minutes?
Sure,
The
sure.
you see, we had worked out for some of our clients some numbers, and they're not looking very good. I mean, at the current rate that they are getting from the OMCs, even if I add a bit to the fertilizers and stuff like that, it is difficult to see. And the cost you guys are talking about, 6.5 crores per ton per day. I'm not getting 6 7 years. It's going to towards 10 years or more. So I'm just wondering, maybe we are missing something.
Yes, sir. We can discuss one-to-one whenever you are available. So based on that, I can guide you. And yes, there would be another good news to the industry, maybe in another 2 or 3 weeks. Price is going to be increased for the CBG. So let's wait and
Very
watch for
good.
the good news.
That can help. That was one. As I said, these are questions I'm not expecting all the answers right now, rather putting the seeds in your mind, because these are questions I ask, these are questions I have. I'm sure there are people who want to ask the same questions to you face to face. Let me just see what are the questions I put for you. Yeah, the current projects, two questions, both related. One, what are the current projects you guys are involved in CBG per se? And secondly, is there any Napier grass uh, in those projects?
Yes, we have been associated with JSW Group. So it's a group from JSW, and they have been doing extensive research and study from past 3 years. Okay, so I have been particularly on their board as a consultant and representing them. We have already installed one plant in Punjab, which was about to commission, but due to the farmers' protest, it got stopped. And we are installing one more project in Maharashtra. And whatever I suggest or I believe is in a small, as normal projects rather than mega projects, what everybody is talking about 10, 15, 20 TPD. Because yes, generating gas is not a problem, but what are you going to do with the feedstock? Feedstock management, as well as your organic slurry, as well as solid organic manure management. So that is still not in place, but people are talking about 20 TPD, 40 TPD of CNG, which looks very vague for me. So I target 2.5 to 5 TPD, not more than that. And several projects have been associated. Like one of my project would be commissioned in another 30 days from now. So January 15 to 20, we are going to commission on press mud, and similarly one project on Napier gas again the same day. So maybe within a month's time, we would be commissioning both the projects in Maharashtra.
These are going to be based on
Press mud and Napier. Press mud and Napier.
so
Napier gas.
these are going to be mixed together, Napier grass and
Yes.
press mud together.
Yes.
And what? Okay. And related questions, since you spoke about guys being very ambitious with their capacities, what do you think is an economically optimal capacity in terms of tons per day?
So anything between 2.5 to 5 TPD is good. Don't look at the Excel sheets or the numbers which you are calculating on Excel. You will never be able to match those numbers, and it will be only on Excel sheet. So you need to understand that whatever efficiently you are operating the plant at 90% or 85% CUF, then yes, it's a wonderful achievement in the biogas industry. So nothing is 100%. So you need to take care of that as well.
And you mentioned also, if it is going to be a 10 TPD plant, it's going to be 6 to 6.5 crores. So what we are talking about for that plant, 60 crores to be put in?
Yes, sir.
But I'm just last question. I know I know some of these have to be answered face to face. You see, if I put a paddy straw or a Napier grass, I'm going to get maybe 5 to 7 tons, or maybe even 8 tons per 100 tons of the feedstock. Whereas if I put in MSW, it's going to be 3 to 4 tons. So are we still sure that you are getting double the yield in the case of paddy straw? But are we saying that the capital cost is going to be shoot up dramatically from the use of MSW to paddy straw? You get it right, because you are quoting capital cost in terms of crores per ton.
You are calculating two different raw materials, where MSW is completely different feedstock, where you don't have to pay for the raw material. You are getting the raw material for free. At the same time, you are getting the tipping fee on the second part. When you're talking about paddy straw, yes, you need to have already the prices at a premium level now, which is ranging from 2 rupees 50 paise to 5 rupees already touched. So all these factors pile up and will give you a different payback period. So raw material, when you talk about paddy straw, again pre-treatment is a must. But in case of your municipal solid waste, normal pre-treatment or hydrolysis is more than sufficient, rather than any costly extrusion or any of mechanical physiochemical treatment. Okay. Secondly, you're comparing 16 to 18% total solid content with 90% total solid content or 85% total solid content. So this is where the figures are ranging. So we need to bring down every aspect on the same page, and that's how I've tried to bring the gas price to the project cost, so that per cubic meter cost was derived by me, so that it would be very easy for the entrepreneurs or the people to understand that yes, across the feedstock, the price would be completely different, considering different pre-treatment techniques or your equipment selection.
What I take back from you, Srinivas, and I think that's a very important message for all you guys here, because I know a large percentage of these guys, 118 fellows I see here, a large percentage of them want to invest in it. Is, look, all these are ballpark numbers, metrics, but there are so many variables. I think unless you sit with guys like Srinivas or anybody else who is putting up a plant and take maybe a week taking all the inputs into consideration, you are never going to get a number which is close to reality. This general metrics, plugging them into a spreadsheet and getting the results is useless. So I think that is what I take from him. Well, the questions I asked him also, it is clear to me that that's probably not the best way to ask the question. Yeah, the question itself has to be framed differently, and then the numbers pan out very differently. I think that's the message I take for me as well as to all the investors. We have to sit with these guys case to case basis. What is the feedstock? What is the technology we are going to use? And finally, look at where the numbers lie. And also, obviously, we have to put in some numbers on what percentage of the fertilizers we can sell. Unless we get all these, I think we are all just talking very random numbers. And when you're going to invest hundreds of crores, it's a bad idea to track random numbers. Thank you, Srinivas. Thank you for your time.
Yeah. Thank you, sir. Thank you for being here today, as well as I wish you, as well as the entire team, whoever is present, a very good evening. And it was an honor to present my perspective here today. So thank you once again.
Thank you, my friend. Thank you.
Thank you, sir. Thank you. This was a very interactive session.